Good day, ladies and gentlemen. This is Sarah van Grenen, aka Mr. VG, and I'm busy with Analytical Geometry question 3.4. Please, if you haven't seen the previous video about question 3.1 up to 3.3, watch that video first. This video is not going to make any sense if you haven't watched that video first. Remember, I'm busy with a series on exam preparation, specifically looking at the Department of Basic Education 2021 paper 2 for this set of videos. In this set of videos, we are specifically going to look at question 3.4, where this is the question relating to the that set of questions 3.1 up to 3.3. The sketch as well you can find on the previous video, or if you want to download the whole question paper, it is available on our online site at www.juniortikkie.online. But you can go and find this paper even on other site on the Department of Basic Education as well. They have it. But on our site, there's so many extra resources about analytical geometry, about trigonometry. There's so much. Please go and find our website. Now, when we have a look at this specific sum, I want you to again try it yourself before you look at the rest of the video. So hit the pause button and try it. Now, question 3.4 goes on where we left off at 3.3. So it says there, another point, T, P, comma, P. I love to again just say what makes it special is the P and the P is the same value. So I've got the same X and the same Y. Where P is bigger than naught, that's important. We'll see later on why. And it is plotted such that ET is equal to BE, and both of them are equal to 4 root 17 units. So the first question is, calculate the coordinates of T. I want to just highlight how many marks? 5 marks. That means it could take you anything between 5 and 8 or 10 lines to do it, depending on the examiner. So it's a bit of a meaty sum. But let's look at how I analyze this. So it says P, or another point T, is given such that E, T, and remember E is the set of coordinates 12, 0, and B is the set of coordinates -4, -4. Remember, we got that in question 3.1 or 3.2 already, okay? And they tell me it is 4 root 17 units. So automatically I'm thinking it has to be distance formula. Why? Because they tell me there's a distance involved. The beautiful thing is that I can now say the distance of ET, and I'm just using the coordinates that's given, okay? And just simplifying it a little bit, okay? So I'm just getting the distance between E and T. P minus naught is just P squared. This must be equal to the distance of BE, which is 4 root 17. You can go the long route and do it yourself, but they gave it to you there, okay? They gave it already. So let's equate these two expressions. What must we now do? We need to solve P. So I'm going to now go and step by step solve for P. First of all, I need to get rid of the square root. So I'm going to square both sides. I'm multiplying out my expression under the root. Remember, this P minus 12 squared, you can write it out. P minus 12. P minus 12. Remember, you can write these things out, okay? Then I'm going to get equal to naught. Why am I now all of a sudden getting equal to naught? Because remember, it is a quadratic expression. So I need to have equal to 0 because this is a quadratic expression. I'm going to divide straight through by a 2 to make my factorization easier. Factorizing for p, I get p as being either 16 or -4. But which one is it? Now remember, always look back at the information that they gave you. P is greater than 0. So in other words, P cannot be -16. What does this now actually mean? Remember, it means that T is 16, 16. Don't forget to just write that in, okay? If I now look at the rest of the question, okay, so I've got now T, I've got E, I've got B. I'm going to look at 3.4.2. It says they determine the equation of the circle with center E. So 12, 0 is going to be my center. And it passes through both B and T. So if I look at my first question, I'm going to substitute the 12 into the A for my circle and the 0 into B because they tell me it's the center of the circle. Now I can choose at this moment of time, how am I going to calculate the value of R? I can go and substitute a set of coordinates in. Let's say I pick -4, -4, and I substitute that in. Then I get a value for R squared as 272, which means I've got x minus 2 squared. Then remember, y minus 0 is just y. And if I say y squared, that is equal to 272. Okay? But now, as I look at this, I sit back and I wonder, why on earth was this actually worth only 2 marks? That's a lot of writing for 2 marks. So what must I think of? Oh, but wait, do they not actually give me the radius as BE? And they even gave me the value as 4√17. If I square both sides, I get 272. Oh my goodness, I could have just used the information I've given in 3.4.1, which means that's exactly the same R squared I get on the right-hand side without substituting any values in. Wow, Matrix, why did I not think of that? Oh my goodness. You know what? It happens. But I'm showing this to you so you see there are different options. There's sometimes a shortcut and a long way. Remember, if you get 80s and 90s, then look for those shortcuts. If you are a 50%er and you see substituting in and getting answer, and it's not the shortcut, just get the marks. Make sure you don't make silly mistakes and get the marks. If you see the shortcut, fantastic. If not, just get the marks and move on with your life. Let's look at question 3.4.2b. The tangent to the circle BK. Okay? So what I'm doing is I'm just drawing my imaginary circle there. And I've got E as being my center. And now they're saying that there's a tangent, and I draw it in this red dotted line there, 2K. And they're asking me for the equation of the tangent. So I know there's a 90 degree between EB and the tangent. Why is that? Come on, Gr12s. Why is that? Because the radius is perpendicular to the tangent. So if they're telling me to get the equation of a tangent, I'm going y equal mx plus c. With m, I've got 4 options. Remember that. Always keep it in mind if you get stuck. Ask yourself, what options do I have? Well, I have now a 90 degrees. And remember, in 3.1, 3.2, you got the gradient of BE to be 1/4. So I can now calculate the gradient of the tangent by going the m of the radius times by m of the tangent must be -1. I'm just going to now solve my tangent. So my tangent ends up to be -4. So I've got the equation of the line as being y equal to -4x plus c. And through what point does this tangent pass? Well, it passes through -4, -4. So I'm going to substitute that in and calculate c. So c is -20. And that makes sense, again, because it's going to cut my y-axis somewhere here at the bottom. So definitely it must be smaller than 0, which gives me a final equation of y equal to -4x minus 20. Wow, I love mathematics. I love analytical geometry. And I want to encourage you. Try it, do it, practice. Practice. If you're struggling, sit with a friend that can help you. Go to your teacher. I promise you your teacher would want to help you. Or just go to a mate that's doing really well and sit together and brainstorm, especially just practicing. Because everything you do, the more maths you do, the better you're going to become. That's such a wonderful, amazing thing you need to realize, is the more maths you do, the better you're going to become, the more chance you have of success. So this is Mr. VG signing out. Please tune in for our next video carrying on analytical geometry, more detail about circles and all of the intricate, wonderful little things that comes with circles. So have a beautiful rest of your day. Keep well. Cheers.